Okay, let's talk about the first problem. And we know that the sigma k equals to 1 to infinite with the px equals to k should be 1 because it's the total probability will becomes 1. And according to the formula, we first know that sigma x equals to 0 to infinite with the p to the power of k, the sum of the sequence should be 1 minus p under 1. And if we take the derivative from both sides of the formula, we will get that this one. And if we take if we go on to take another differentiate on p on each side of the formula, we will get this one. And finally, we will have, if we continuously take a differentiate on both sides of the formula, and we will finally get this one. And all of these are going to be used in solving the following problem. For the first problem, we know that since this formula, that b multiplied by sigma from k equals to 1 to infinite, k multiplied by p to the power of k minus 1 should be 1, and we know that these things should goes to 1 over 1 minus p to the power of 2, so that we know b equals to 1 minus p squared. And for the expectation of x, we can get that it is x multiplied by sigma p for x equals to k. So we know that x should be equal to k in each case. So the expectation should be b multiplied by k squared and multiplied by p to the power of k minus 1. And since we have this formula, we have this result, and we know that b equals to 1 minus p squared, so the expectation of k should goes to 1 plus p over 1 minus p. And similarly, the expectation of x squared should be b multiplied by k to the power of 3 and multiplied by p to the power of k minus 1. And since this result, we will have the final result with b equals to 1 minus p squared. And the fourth problem is simply done by minusing the result from the second one and square it to the result of the third problem, and we will finally get this result. And what about if we know that b equals to 4 out of 9, and we can solve that p equals to 1/3. And the problem is a conditional probability, so we can change it to the joint probability divided by the marginal probability. So first is the upper one. We can change it into another conditional probability multiplied by the margin probability. So what about this one? Px is larger than 2 and less than 5, given x equals to k. It is surely will be for k equals to 2 to 5, the probability must be 1 and 0 otherwise. So we will divide it into two cases. So for k equals to 2 to 5, and otherwise we will calculate the conditional probability, the problem asks. So it will be 81 on 98 and multiplied by k and 1/3 to the power of k minus 1 for k in 2 to 5, and surely since the this probability will be 0 otherwise, so the final result will also be 0 otherwise.